Here it is. All right, let me throw this on the screen. Morning, Luke. Mood check in. There you go. How are things going this morning? Mary's with us. Hello, Mary. 5. Cadence chill. All right. Oh, got a few chill going here. Morning, patience. How are you this Monday morning? A lot of twos. Bah. I'm awake. Daniel's kind of being a blah chill, little chill blah, something there. A lot of blah, a lot of chill. I guess that's better than like sad or scared or angry. That's not a way to start our week. I don't know. I'm on the board. I'm on the verge of a 3, right on the border of excited. It is the last week before spring break. It means things are happening. See, I got the wedding coming up on spring break, so that means the wedding's almost here. I'm not finished with all my chores I've been assigned for the wedding yet, but I'm working on it. Working on it. All right, a lot of blah, a lot of chill. All right, we can go with that. Yes, I was given a chore by my daughter for the wedding. I'm supposed to come up with a story for every year of her life. A story when she was 0, a story when she was 1, a story when she was 2, a story when she was 3. So I've got about half of those so far. It's hard to remember a story when you were like 4. I'm having to go back through old photos and look at photos and kind of refresh my mind of what was going on during that time period and say, oh, yeah, man, I can come up with a story. So, like I said, I've got to have, and I'm trying to make it an entertaining story, not just like, hey, she went to 3rd grade. She did good. She got S's. That's not a story. A story is something that informs and entertains. At least in my opinion, it should entertain. So I'm trying to come up with entertaining stories. But I'll get there. She wants these all formatted and printed out and put on the tables at the reception. So everybody's got a story from some age that she was. So I'm getting some pretty good ones. I'm just trying to fill in the gaps now. It's like, oh, I need a 3-year-old story. I need a 9-year-old story. And, I've got about half of them. All right. Well, we've got most everybody here. We're missing a few. They'll have to catch up with us. Let's take a look at what programming holds for us this week. What kind of exciting things we have in store. Last week we had a program. There's several of you have not turned that in yet. So, I know what your spring break's going to be doing. Getting caught up in programming. Let's see, foundations of programming right here. Let's take a look. Let's go to our grade screen as usual. All right, so we are in module 5. Last week was 5.02, decoding ASCII. So that was the program that was due last night. I know several of you have got that turned in, over half of you, but there's still many folks that have not written that program yet. So getting behind. All right, let's look at 5.03 this week. Activities, procedural and object-oriented programming. We call that OOP, object-oriented programming. So if you make an OOP in here, that's not necessarily a bad thing. Programming design approaches. All right, we're going to talk vehicles today. Sedans, SUVs, trucks, campers. They're all vehicles, right? So we have this little changing photo over here from color to black and white. Interesting. So yeah, these are all vehicles. They got wheels, doors, brakes, tail lights, air conditioning. If you're lucky, you got air conditioning. Each of these pieces makes up a vehicle, right? Some have different features, like different colors. Some have more specific uses, like, you can drive off-road, but I wouldn't do that in like a little microelectric smart car. Wouldn't go off-road in that. But they're all considered vehicles, even though they have different purposes and differences among them. Vehicle manufacturers could create each one from scratch, depending on the color, the size, the engine type, or they could create a template and mass produce them. Put them on the assembly line like most vehicles are made. tweaking certain parts for variety. We'll paint this one this color, paint this one this color. We'll give this one a fancy stereo. We'll give this a plain stereo. This will have navigation, but still they mass produce these cars. But what about airplanes and rocket ships and like horse-drawn buggies? Well, technically those are vehicles. Those are vehicles also. So what do they have in common? They transport things, right? They require a driver in most cases. We're starting to get around that too. They go to and fro. A lot of them go fro. Most of them go to. Remember how we were talking vehicles? We're really talking about program design approaches. So in this lesson, we're going to be able to define procedural and object-oriented programming, compare procedural and object-oriented programming, and discuss the advantages of using object-oriented programming. Let's check out page 2 on this. Procedural versus OOP, object-oriented programming. The term design approach, you've heard that perhaps, design approach, refers to the way a programmer thinks about his or her code. This choice of approach can vary by project or by programming language. You may take a different approach if you're using a different language. There are two main design approaches that are used in programming. First is procedural programming. This is a programming design approach that divides well-defined tasks into modules, functions, or procedures. We've done a lot of this already in this class. We've done different functions. When we were doing the turtle graphics, we often have different functions that had well-defined tasks. This function drew a tree. This one drew a spiral. This one drew a star or whatever. We use different functions or different modules. So when you're learning to program, you often start with a high-level description of what you want your program to do, and then you break it down step by step into the functions you need, right? This is what the big picture is. How do I do that? Well, first I need a function to do this, and then I need to write a module to do this, and then this. That's why we do our pseudocode. Got the big picture, breaking it down. What do I need to do to write this program? Well, I need to have an input statement where I ask the user this. I need to compare that to this list, whatever it is. That's what our pseudocode is for. So you do this when you write programmer-defined functions. You take it one step at a time. You decide what your function is going to do, next what it's going to be called, and then how's it going to work. As you go, you write the code needed to execute your program. So manufacturing vehicles from scratch would be a lot like this. The other design approach is known as object-oriented programming, or OOP. So that's a programming design approach that focuses on objects rather than functions, referred to as OOP. In OOP, the programmer thinks in terms of objects rather than functions. Objects are defined using a class. That's the attributes and behaviors that describe one category of objects. Objects are an instance of a class that encapsulates its own attributes and behaviors. We'll get more into this here. And there are parts of the program that can carry out certain actions and interact. Like manufacturing vehicles from a template is more similar to OOP. Let's take a look at some of the differences so we start to understand better what's procedural and what's object-oriented programming. So let's look at the description. In procedural, an approach to program that uses a list of functions or procedures, tells the computer what to do step by step. In OOP, it's an approach to program that uses objects to carry out different actions. Let's look at the application of this. Procedural program is known as top-down design, right? We'll start at the beginning. We'll work through every step, exactly through that. But with object-oriented programming, it uses classes to define and create objects for a program. Programmers write code and have objects interact and perform actions. Languages. So early programming languages, including Fortran, COBOL, C, and BASIC, are mostly procedural. BASIC is a language I learned when I was in high school. Most of today's newer languages like Python, Java, and C++ are object-oriented. Now, we've taken a procedural approach, but Python is very good at doing object-oriented programming. Here's an example. If you were planning a party the procedural way, you'd list all the steps that need to be done. I need to send the invitations. I need to buy the food. I need to decorate for the party. I need to make a playlist. I need to prepare games. Right? You're planning your party. If you were using OOP, planning a party the OOP way, you would call the object party planner that you used for your last party and have it do everything you need. You already had written a party planner last time. That module is set up, that object is set up, and you would just refer back to party planner. Boop, go back and do that again. That's why Python's good. That because Python has all these built-in modules that we don't have to write it piece by piece. We could just, import math function, import turtle, things like that. While procedural programming is a logical way to think about writing code, object-oriented programming is also pretty intuitive. Once you define a class, it's easier and easier to create new objects. But OOP does require more planning up front because more objects means more complex programs. So let's dig into some of the nitty-gritty of the OOP. Alley-oop? No, not Alley-oop. I don't even know if they run that comic anymore. Alley-oop, that's an old comic strip. It was around for decades. OOP vocabulary. Most things you encounter daily are objects. Cars, furniture, even your phone. For each object, you can customize the way it looks. You may have the exact same phone as somebody else, but you've got a different case. You've got a different screensaver on it, whatever. You've got all kinds of different looks. You can customize the way it looks, its different features, what it can do. And we define objects by their different attributes and behaviors. These real-life objects can be simulated with program code. Just take a look at this image to learn about some of the important terminology related to OOP. All right, so we've got our phone here. We've got our contact up with Monty Python. There's his number if anyone needs to call him. His email is monty@python.com. His ringtone is waves. Defaults to vibration. No tone for texting. Let's look at this right here. Add photo. We'll click on that. Constructor. This refers to the code that allows you to create a new object. It's a special method used when a new instance of a class is created. So the initial values of the attribute are set. This is like adding or constructing new contacts in your phone. Okay. Oh, let's turn that one off. Class. This refers to a template used to create new objects. Like when you do new contact, there's this template that pops up. Think of it as a blueprint. It has the existing characteristics you can use when creating new but similar objects. Each time a new contact is created to your phone, it uses the contact class. So this is when you added a photo, right? There's already a method to do that. And this, you just click on that and it's ready to add the photo. You don't have to write all the steps needed. Let's look at this button here. Instance. Many instances of a class can be created. For example, an object is an instance of a class, like this contact right here, or Monty Python. One individual contact in your phone is the instance of a contact object. So an object's the individual part, where this over here was the template used to create the objects. That's the class. All right, let's go this over here by the done button. Initializing. This refers to what the constructor will do when you use it to create a new object. It will initialize the object in the program, and when you create a new contact, all of the attributes will have the initial values. What does it default to when you first pull this up? Let's check here by mobile number. Attributes. This is some of the features of an object. The attributes of a contact might include a phone number, email address, picture. Attributes are often nouns and adjectives that define the properties or characteristics. But it's things that differentiate one contact from another one, right? One object from another. And look at the ringtone. Behaviors. They're also known as methods. This refers to the actions that an object performs. So this object, when Monty Python calls, this is the ringtone it performs. The waves. You can set specific ringtones or vibration patterns to a specific contact. So when that specific person calls, that specific behavior is performed. So based on the object, it can have different behaviors. All right, programming spotlight, Mark Zuckerberg. Perhaps you've heard of him. Born in 1984, so he's turning 40 this year. He was voted least likely to succeed. Look at that. Dropping out of college his sophomore year at age 19, it would seem that Mark Zuckerberg was not likely to succeed. Drop out. But we all know that's not true. That Facebook co-founder began programming at age 12, and he was a billionaire at age 23. The Facebook interface makes use of object-oriented programming. Because when you create a new account, there's a template. Each account created is an object, right? So it uses classes to make new objects, including user profiles, React buttons, notification features. All right. Advantages of OOP. All right, it's got a lot of advantages. There's a reason it's the way that most programming has evolved into OOP today. Let's check out some of the benefits. Reusable code. Once programmers write a useful class for one programming project, they can often reuse that in another program instead of starting from scratch. If you got this loop that does this wonderful graphic you did in another program, you can just copy that and bring it forward to a new program to be able to do the same thing. If you create a class for a deck of cards, you can reuse it for any program you write that needs a deck of cards used in it. If you're writing a solitaire program or Go Fish, you don't have to start from scratch every time. Inherited traits. Programmers can create new objects that inherit traits from existing classes. That means they can add new features to an object without having to recreate it from scratch. It saves a lot of time, a lot of effort. Like if you need to create a vehicle class that has all the basic functionality of a vehicle, it moves, it carries people and things, it starts, it stops. You know, you could build on that class to create more specific types of vehicles. Okay, I'm going to create a convertible. I'm going to create a bicycle. I'm going to create a semi-truck. Flexibility. Programs created using OOP are easier to develop because of their flexibility. Objects can be used in a variety of ways and have different programming behaviors for different purposes, depending on the program there. Like if you create a class for your bank account, many bits of information are needed to open an account. Your name, social security number, your birthday, just so they can make sure when anyone comes to take money out of that, they know all those things that matches you. Or to get a loan. But for simple transactions like making a deposit, really you just need your name and account number. Your bank account class could work for all of these. Yeah, they don't care. You don't really care about the security if someone wants to deposit money in your account. If it's you or not you, you don't really care as much. Who's going to deposit money in the account if it's not you? Well, hopefully lots of people. I don't mind how many people want to deposit my account. But when you take money out or get a loan, it needs some more verification there. Easy to maintain. Object-oriented programs are written modularly. There's modules. Makes them easier to maintain and understand once they're developed because you just have to know which module is not working. You can go look just at that portion. Like if you're planning a meal and you burn the cupcakes, you only have to redo the cupcakes. You don't have to do the whole meal again. In OOP, objects can be maintained separately. That makes finding and fixing problems much easier. So, all right, that's the end of that. Page 5 just says, read the lesson, do the assignment. So let's look at the quiz that goes with this week. All right, 1, 2, 3, 4, 5 questions, all multiple choice, nothing you have to write in. So make sure you understand the lesson, answer these questions. Let's get some easy points here because the answers to all of this were on those pages we just read. So you can go back and review whatever you need to there and do well on that. So, all right, not a bad week, easy week. That's good because spring break's next week. So if you're caught up with all your programs, you could be on spring break for this class in an hour, in less than an hour. As soon as you're done with this, you're on spring break. That's how I recommend you treat all your classes. Get your work done early in the week. Make your spring break longer than these people are in the building. Right? These students in the building, they don't get to start spring break till Friday afternoon. You can start a lot earlier. Get everything turned in for your classes. Party. All right, guys, have a great spring break. If you have problems, if you haven't got a program written and you're trying to get caught up, get that done. If you're having errors, get with me, email it to me. Mr. Brock, I've got an error. I can't figure this out. My program's not working. I'm happy to help on that. So I know a few of you have programs turned in. I haven't graded yet. I'll get those done today. Note, I will not be here tomorrow. That doesn't affect this class, but it could affect you if you're emailing me something because I won't be able to get your email back tomorrow. I got to go to Little Rock, have a checkup, seeing my oncologist. No worries, no cancer back that anyone's aware of. So it's just a checkup, which I do 2 or 3 times a year. So we will see you guys next week, unless your grade's below 70%. It is a B day Friday. So we have class Wednesday for those of you who need to be here. See you guys. Have a great spring break.